Hello my dear students, today in the second lecture we will continue from the lecture 1 where we discuss about the syllabus of this course EMFT, and we have started the unit 1 with the basics of the vectors, right. So, now we will continue from there and some part of that we will cover here itself, so that your base must be good. Okay. So, in that we are talking about the vectors and we will pace now, so that you can cover most of the topics in our this course, right. So, vectors in the Cartesian or rectangular coordinate system, which is very much aware to all of you that x, y, z, we say this is the Cartesian or rectangular coordinate, right. So, how the vectors is representing? The vector A can be represented as ax, ay, az. These are not the point, these are the components. So, two things which are you have to keep in mind in the vectors. First one is the point, second one is the component. So, we will discuss about that, what is point and what is component. So, first is the component is what? Any vector A is represents. So, this will be represent the vector A is ax in the direction of ax, ay in the direction of ay, az in the direction of az. So, here you can say if any vector A is given, so this is the summation of the component in all the three directions. Ax unit vector, ay unit vector, az unit vector. So, vector A will be represent as the ax into ax and ay into ay and az into az. So, when you add these three vectors, so in that case we will get the vector A, right. So, this is a representation of any vector in the graphical form. Then magnitude of that vector is defined as ax square, ay square, az square, and the unit vector from here is the aa is equal to a upon mod of a. Okay. So, we have defined this, we have given this definition. Okay. So, sometimes you will see that the vector A is written like this. So, you can write in the bold letter, but if it is not possible that all the time when you are writing the answers and you are mentioning in the bold letter. So, better way to represent the vector is just take the arrow at the top of the alphabet. Okay. So, it will become the vector, and to represent the any unit vector, so you can represent this one as the bold of A, or you can use the cap. Okay. So, this is a very good way of writing the unit vector and the any vector. So, this one is what? Mod of A. The mod of A is given by this magnitude of the component of the vector, and here the vector A divided by the mod of A. Okay. So, this is the unit vector. And what is the use of the unit vector? So, this unit vector is used to provide the directions. Then now come to the vector addition. So, vector addition is very simple. The two vectors, if you want to add the two vectors, right. So, that is the vector A and the vector B. So, in that case the addition of two vectors will be what? Vector A plus vector B is equal to vector C. So, this is vector C is equal to vector A plus vector B. So, this is the component wise direction wise addition, right. So, direction wise addition is what? Just like vector A is in the direction of x, ay is in the direction of y, az in the direction of z. Similar to that, vector B will comprise the B in the direction of x, by in the direction of y, bz in the direction of z. So, when we add these two numbers, then as I said direction wise addition will be there. So, ax will add with the bx. So, in this case ax plus bx will be ax into ax plus ay into by into ay. Then az plus bz is into az. So, these are the components ax plus bx. Ax is the unit vector, ay by, ay, az plus bz, az. Okay. So, this addition can be represented in the graphical fashion, vector A, vector B. So, the resultant of these two vectors is the addition of that. So, in this case vector C will be A plus B. So, for the addition, this is very important, you have to put the tail of the two vectors, right. So, tail of the two vectors you have to add, and then you can represent the vector C. So, their representation first is the parallelogram rule. So, by this, as I said, second is the head to tail rule. Okay. So, very simple, you can use this one as the, if you are writing vector b here, so this parallel of vector b is what, this one, right. So this is the parallel vector b, and this again the vector b. So in this case this is a parallel vector, we can also say this is also the vector b, and this one is the parallel to the vector a, so we can say this is also the vector a. Okay. So now you can say when you take this one graph, and you can represent this one as well from there. So what is that? Vector a plus vector b is equal to vector c. So we call this one as the head to tail rule. So very simple. In short manner, you can write vector a, then you can write the vector b, and what is the addition of vector a plus b? This is the vector c, right. So you have to keep in mind how we can represent the two vectors when we want to add the two vectors in the mathematical form or the graphical form. Then we have the subtraction. Subtraction is nothing but again the same thing, we are adding the two numbers or the two vectors, but second vector will be in the opposite direction. Very simple. So vector a, again the same example we will take, vector a, vector b, and when we go for the subtraction, so in that case what I said, the subtraction will be what, again vector a plus vector b with the opposite direction. So this is become a minus b. So to represent that, vector a, vector b, as I said the addition of two numbers, b ko kya karna, what you have to do, reverse the b. So b will reverse with the minus b, and resultant of a and minus b will be d, right. So in this way again we can represent the subtraction in the using the parallelogram rule and the head to tail rule. Same thing is there to represent the addition and the subtraction of the two vectors. So they are the rule, some law of algebra which can be used for the addition and the multiplication, that a plus b is equal to b plus a. This is the commutative rule. In the associative rule, a plus b plus c is equal to a plus b and then plus c. Distributive, in that k is the sum and scalar, and in that a plus b, when you multiply scalar into this bracket, then we will get the same result. Then in the multiplication, k a is equal to a into k. Okay, so a is the vector, and k is a scalar quantity. Here as well, when we have the k scalar, l scalar, and we multiply with the a, so in that case k l into a. So I hope this point is clear to all of you, and you can also verify all these things by, see, if in an exam they are asking about the define the commutative rule of two vector, commutative rule. So what you need to do for the two vectors, just take the vector a and vector b, define the vector a as the ax, ay, az, and vector b as the bx, by, bz, and just simply add in this way, and finally you will get the result. Same result you will get, a plus b will be equal to b plus a. And you can also define and verify the associative rule, distributive rule for the addition and the multiplication. So this is the law of algebra, so which you have to take care of. Next topic, very important, the position and distance vectors. So for that, for point P in the Cartesian coordinate, as we are simply defining the position vector is nothing but it is represent the point P from the origin. Okay, point P from the origin. Okay, so you can say that position vector RP for point P is defined as the directed distance from origin to point P. So in this, RP is what? This RP is from origin to the point P. Okay, so this is the position vector. So position vector from always will be from the origin, OP. So in this case, if I want to represent this point P at 2, 3, 4, 5, which has the position vector. So what is the position vector for that? 3a, 4ay, 5az. Okay, so this is the position vector for any point, these 3, 4 and 5. Distance vector. So, this distance vector is the displacement from one point to another point. So, how to represent that? First of all, we have to represent the two position vectors and we subtract these two position vectors and we will get the distance vector. So, like that, P is the point, Q is the point. For the P point we have the XP, YP and ZP, and Q point we have the XQ, YQ and ZQ. So, in that the distance vector will be what? P R PQ, that is RQ minus RP. Okay. So, in this case the position distance vector will be XQ minus XP into AX, XY minus YP into AY and ZQ minus ZP into AZ. So, you can also define, how we will get this RPQ. So, in the whole syllabus, one thing you have to keep in mind, what is that? We know the addition of two vectors is equal to C. If you remember this small rule, then most of the numericals you can solve very easily, right? Just like there is no need to do anything by heart, right? So, in this case you can see, which I said A plus B is equal to C. So, you can see A is what? RP, B is what? RPQ, like A plus B is equal to C. So, you can say like RP minus R PQ is equal to RQ, right? A plus B is equal to C, right? A, B and C, right? So, A plus, it will be plus, A plus B is equal to C. So, in this case what is R PQ? This will be equal to RQ minus RP. So, there is no need to mug up the things, right. So, you apply the basic laws of algebra, then things will be very easy, but the students make the mistakes in that. Directly they write this in this way and sometimes they forget and sometimes they make the mistakes, silly mistakes in that, and small numericals will be wrong. So, better way is just remember the C, A plus B is equal to C. So, simply apply that if you are confused, right. So, if you are little bit confusion, so do not assume anything, just follow this basic law of the algebra. A plus B is equal to C. So, in this case RPQ will be RQ minus RP. So, one numerical you can see means what are we understood till now about that. So, one numerical we can follow that. Two vectors are given, vector A 10 AX minus 4 AY plus 6 AZ, vector B is given 2 AX plus AY. Then we have to find the component of A along AY, magnitude of 3 A minus B, a unit vector along the A plus 2B. Okay. So, component of A along AY, so very simple, component of A along AY is what? Minus 4, clear. Magnitude of 3 A minus B, how you will solve? So, take the vector A, multiply with the 3 and just simply subtract the B from there and take the magnitude of that. So, the definition, as I said, if you remember the magnitude, so in that how you will get the magnitude for that? So, this value will be minus 4 as we said, this value how you will get the 3A minus B magnitude, you have to do in this way. Next is unit vector along the A plus 2B, the unit vector along this. So, how you will get this unit vector along A plus 2B. So, what is the thing which you have to calculate? Unit vector definition is what? This is the vector, this is the vector divided by the vector magnitude. This is a very basic formula which we are discussing about that. A, unit vector A plus B is equal to A plus 2B vector divided by the A plus 2B. Okay. So, addition you are very much aware how to do the addition of that one. So, the resultant for that one is this. AY is equal to minus 4, as I said, the component of A along AY, right. Then I said the magnitude of 3A minus B. So simply take the multiply 3 with this component of A minus B. So when you do this calculations, then finally you will get this answer. And I said the magnitude, then the magnitude is 3A minus B ka whole. So in this way, 28 square plus minus 13 square plus 18 square, that value will be 34.74. Then the C part, as I said, the unit vector. So unit vector is given by this one, vector C divided by the mode of C. Okay. So C is what? This is the A plus 2B, as I said in the previous. This is nothing but they are representing the C. So in place of this we are writing the C. So C is A plus 2B. So A plus 2B. So when you solve this and then take the magnitude of this value, and when you are solving this one, then resultant will be this much. And very important point is, no one is asking about the magnitude of this. So when you go the magnitude of this one, so it will be 1 only. So you can verify your answer as well. So the magnitude of the unit vector is 1. So what are result you are getting from here in the vector form, in this form. So you can see that when you take the magnitude of this 0.9113 and 0.1302 and 0.3906, when you take the magnitude of this one, then you will get the 1. It must be 1. If it is not 1, it means there is some mistakes in the calculations. So this is very, very important, which you have to take care about this numerical, I mean the basics of that one, right. Similar to that, next example, again you can try. 2 points P and Q are located. These are the 2 points which is located here. The position vector RP, just think about that. Position vector RP. So as I said, this position vector will be from the origin. So the value which you have to calculate, that must be your, that is equal to ROP. You have to find that one. So as I said, these points are given 0, 2, 4, minus 3, 1, 5. So the RP will be what? From the origin, it will be 0 AX plus 2 AY plus 4 AZ. Okay? Now distance vector from P to Q. So when from P to Q, what you need to do? You have to find the RP and RQ. And what you need to calculate? You have to calculate the RP. Okay, so this is the Q, RPQ. You have to find this one. And this formula you are aware now, RQ minus RP. Clear? So you have to do that one. Then distance between the P and Q. This is a distance vector. Now the distance between the P and Q, you have to take the magnitude of this B part. A vector parallel to PQ with magnitude of 10. This is very, very interesting and very important question, which we will cover here as well. Okay. Okay. So very easy questions is there. So in that RP, as I said, from the origin, 0 AX plus 2 AY plus 4 AZ is equal to 2 AY plus 4 AZ. Then RPQ, RQ minus RP, very simple calculations are there. Simply you have to subtract and you will get the RPQ, that is minus 3 AX minus AY plus AZ. Then we have C, that is equal to mode of this one, right. So this is what C part is the distance between the P and Q. So RQ you can calculate, and distance, these are displacement, right, distance vector from P to Q, or the displacement from P to Q. Distance vector or the displacement, this is a P to Q, and when we want the distance, so distance is a number, scalar quantity. So for that one you have to take the magnitude of this RPQ. So this value will be 3.317, right. Then finally last is the D point, where we said we were asking the vector parallel, a vector parallel to PQ with magnitude of 10. So for that one you have to find the unit vector, then you have to multiply with this unit vector with the magnitude of So any vector which is defined as the any vector which is defined, you have to multiply with the unit vector, simple. So what you need to do, RPQ, you got that. So you have to find the unit vector from there and simply multiply with the 10. So in that case, how you will do? Formula you are aware about that, right? Any vector which is desirable to us, that is mod of A into AI, and mod of A, as we said, the magnitude, that is 10, and since vector A is parallel to PQ, it has the same unit vector, right? So if you can see, if this is the RPQ, so the unit vector which is parallel to this one, that is also the same. So direction of this one and this one will be same. So if this direction is PQ, so this direction will be the same, PQ. So this direction is same, right? That then only that it will be the parallel vectors. If the directions are same, then it is a parallel vector, right? So what do we need to do? Vector RPQ is given, so we have to find what? This one, APQ we have to find, and simply we will multiply with the 10. So we will multiply this one with the 10. That's it, thing which we have to do. So here you can see the AA plus minus RPQ, this is a possibility, maybe plus or minus. Parallel vector can be in opposite direction or in the same direction. Okay, so that is why they have taken the plus minus sign. RPQ divided by the RPQ, right? And this is a vector, this is the magnitude of this one, and simply what we are doing, we are multiplying, we are getting the vector A with the multiplication of 10. As I said, we find this one and we multiply with the 10. So in this case, this we are getting the result. Okay, so vector multiplication. So there are various two types of basic multiplications are there, scalar and the vector multiplication of the two vectors. Till now we have discussed about the addition, subtraction, unit vector, position vectors, distance, displacement. So all these things we have covered till now. So when for the multiplication part, first is the scalar or dot product, that is A dot B, vector or cross product, that is A cross B, right? Then this is the case when we have the two vectors. Now when we have the three vectors, so in that case we say this is the scalar triple product and the vector triple product. So why we call as the scalar triple product and the vector triple product? So reason is very simple. Scalar triple product, in that vector A is there, vector B and C is there. So when you multiply of this one, I mean when we are getting the result of this one, then the result of this one will be scalar. Okay. Similar to that, when we have the vector triple product, again the vector A, B and C, the resultant of this multiplication will be only vector. That is why this is the vector triple product and the scalar triple product. And here itself you can see this is the A dot B cross C. So the B cross C, result of B cross C is a vector and A is vector, and when we are taking the dot product vector to vector, we will get the scalar. Similar to that, vector triple product, A cross B cross C, B cross C is the vector, A is the vector. When we take the cross product of vector and vector, then we will get the resultant is a vector, right? So these are definitions of that one, and how we define this dot products of A and B. So A dot B, very simple, mod of A, that is equal to A B cos theta AB. Okay, so theta AB is the smaller angle between A and B, and vector A and vector B. So simply you can take the component multiplication AX BX plus AY BY plus AZ BZ. Okay, so this is the some property of the dot product. A dot B is equal to 0 when two vectors are perpendicular to each other. So in this case A dot B will be 0, and it follow the commutative law and distributive law as well. Okay, and some properties of that one also, A dot A is equal to A square. Here the cos 0 is 1. Last and very important point is about this one, when we have the AX AY AZ AX, then this multiplication will give the result 0. When we have the same component multiplication, like when we have same directions, ax into ax, ay into ay, az into az. So in that case the resultant will be 1. So this is the dot product A dot B, and in the next lecture we will cover the cross product, and then we will come to the main point, that is the transformation, which is very important. Thank you very much from my side. Thank you.